All right, everybody. Good morning. Today we are going to, I'm going to have you do a little simulation of ionic bonding, and I want to show you how to get to that simulation and how to use it. So if you'll go to your main physical science page, here it is. We are in Unit 5. This is our last week. So click on Unit 5, and you can see Week 8 was last week, and this is this week, Week 9. So click on that. And right there at the top, it says Ionic Bonding Simulator. So go ahead and click on the Ionic Bonding Simulator. And it's going to give you this sad face because you've got to pop this out over here. And it takes you to the web page. And if you scroll down a little bit, you're going to see a periodic table. It's a partial periodic table, but it's got some important stuff on it. You can see the columns or the groups. You can see group 1 and group 2. Remember, groups 3 through 12 in here get skipped, and then 13, 14, 15, 16, 17, and 18. Remember over here, group 18, these are all noble gases. So we're not going to work with any of those because they already have 8 valence electrons. They don't need any more. They don't want any more. They usually don't bond with anything. But you can see highlighted in blue here are some of the more common elements, metals, aluminum, and these 4 over here, sodium and magnesium, potassium and calcium. And then these nonmetals that the metals often bond with, nitrogen, oxygen, fluorine, sulfur, and chlorine. Okay, so we're going to take a look at a couple of examples just so you can see how to do it, and then you all can mess around with as many more as you want to. All right, so choose elements from the periodic table to bond. I'm going to start out with a simple one. I'm going to start out with a metal, sodium. You can see when I do that, it pops up down here. And you can see some interesting things about sodium. First of all, the chemical symbol and the name. The element type, it's a metal. Of course, we knew that because it was over on the left-hand side. And then down here, they show its Lewis dot structure. You can see sodium has 1 valence electron because it's in the first column. All right, so what do I want to bond that with? Well, sodium is a metal, so I've got to pick a nonmetal. You'll notice all the metals disappeared because you can't pick a metal. You can't combine a metal with a metal. So we're going to come over here and I'm going to pick chlorine. Could have picked any of the nonmetals, but I'm going to pick chlorine because NaCl is a very common compound, table salt. So when I pick chlorine, you can see again, element type, it's a nonmetal. All right, don't worry about electronegativity. That's something you'll learn about in chemistry in 11th grade. You can see the chemical symbol and the name, but most importantly, you can see the Lewis dot structure with chlorine's 7 valence electrons. There are 7 valence electrons because it is in that, well, the table disappeared, but it's in that 7th column, right before the noble gases. So sodium has 1, chlorine has 7. So the question is, what type of bond is this combination likely to form? Well, as you might have guessed, we're talking about ionic bonds, so ionic bond is the correct answer. And then the next question is, based on your knowledge of these atoms, how many of each do you need? Well, go back up here. Oops, wrong slider. Go back up here and look. What is the oxidation number? So sodium is in the first column. It has 1 valence electron. It would rather lose that electron and become a +1. Chlorine is in the 17th group. It has 7 valence electrons. It would rather gain 1. So sodium is going to be a +1 oxidation number, and chlorine is going to be a -1 oxidation number. Sodium loses an electron. Chlorine gains an electron. Well, +1 and -1 balance out perfectly. So that means you are, oops, again, wrong slider. That means you are likely to need 1 of each. Submit answer. Correct. And then it kind of shows you the oxidation numbers and then how sodium and chlorine balance out to make the ionic compound sodium chloride. Okay. All right, so when you're done with that, we're going to reset back to the beginning and we're going to pick another 2. All right, I'll do one more example for you. This time I'm going to pick magnesium and chlorine. Okay, you can see again, magnesium is a metal, chlorine again, a nonmetal. Magnesium has 2 valence electrons because it's in the second column, group 2. Chlorine, once again, 7. Since it's a metal and a nonmetal, they are likely to form an ionic bond. And then again, magnesium is a +2 because it's going to lose 2 electrons. Chlorine's a -1 because it can only gain 1. So in order for magnesium and chlorine to bond, +2 and -1, you need 2 -1s. To balance out the charge, this is a +2. You need 2 -1s. So we come over here, and for every 1 magnesium, we're going to need 2 chlorines. All right. There it is. Correct answer. Now, just one time, I'm going to go back and I'm going to pick magnesium and chlorine again, but this time I'm going to give the wrong answer. Yep, ionic bond, sure. What if I had said 1 and 1? Okay. Now that doesn't balance out. We know that, but it's a wrong answer. I'm doing that on purpose. If I submit the answer, just say, oh, it's incorrect. Try again. Okay, how about 2 and 1? Nope, still not correct because you don't need 2 magnesiums. That's +4. All right, so 1 magnesium and 2 chlorines. There you go. Now you know you did it right. Okay. All right, again. So you can now do any combination as long as you have a metal. And remember, aluminum is also a metal. Okay, so it's going to be positive. And a non-metal. You can practice any of those combinations. And I'd strongly suggest you do that so you get ready for the quiz on Friday. All right, good luck.